Today we will discuss Chapter 1, Sinusoidal Voltages and Currents. So this is Chapter 1, not Chapter 10. So last week I posted a video in your MVLE dashboard and I assume that you already watched that video kasi nandun yung diagrams ng sinusoidal voltages and currents. So what is alternating current fundamentals? An alternating current or AC is the current which changes periodically both in magnitude and in direction. So a sinusoid is a signal that has the form of sine or cosine function. So you already discussed in your trigo subject what is sine and cosine function. Okay? So sine, let's recall, it starts at this reference. So AC, fundamentals, alternating current, changes periodically both in magnitude. So your y-axis is the magnitude and your x-axis is the direction. So this is a sine function. It starts at this 0 degrees. At peak, this is 90 degrees. So it has a maximum here. It is either voltage or current. Kasi magnitude, it is either voltage or current. Here, at this point is 180 degrees. This negative maximum here is 270 degrees. And lastly, this will be your 360 degrees. Changes in magnitude and direction is measured in terms of cycles. Each cycle of AC consists of two half cycles, namely the positive and negative half cycles. Current or voltage increases in magnitude and in one particular direction, attains maximum and starts decreasing passing through 0. It increases in opposite direction and behaves similarly to this figure. So in a sine wave, we have two half cycles, the positive here and the negative half cycle. So it is positive because it behaves on the positive sign of your magnitude and also at the here negative. So as the magnitude increases, it attains the maximum here at pi over 2 or at 90 degrees. And it will start to decrease until it reaches again 0. So at 180 degrees. And start increasing at the negative side or negative half cycle until it reaches the maximum at 3 pi over 2 or 270 degrees. And it starts at decreasing again until it reaches 2 pi or 0 degrees. So there are many types of alternating waveforms, such as square, triangular, trapezoidal, but purely sinusoidal waveform is preferred for AC systems. So for square wave, we have like this one. In triangular, like this. And trapezoidal. Advantages of AC. So the voltages in an AC system can be lowered or raised with the help of transformer. In this system, raising and lowering of voltages is not easy. So number 2, as the voltages can be raised, electrical transmission at high voltages is possible. 3, AC electrical motors are simple in construction and are cheaper and requires less attention from maintenance point of view. Number 4, whenever it is necessary, AC supply can easily be converted to obtain DC supply. This is DC. So, generation of alternating EMFs, we have discovered by Michael Faraday in 1831. So, generator action involving the development of voltage may result. So, number 1, we can develop alternating voltage by moving magnetic lines of force in such a manner that they cut across a conductor. So in this figure, we have the stationary part, which is the conductors, and the rotating part is our magnets or the rotor. Number 2 is by moving a conductor in such a manner that it cuts across magnetic lines of force. So a while ago, our stator, which is the conductor, and our rotor is the magnets. In number 2, our stationary part or the stator is the magnet, and our rotating part is the conductor. So at our lines of force is from north to south, this direction, and our conductor, this one, A, B, C, D, and it is connected to a brushes that collects the alternating current, and it is connected to the load. So in the video in our MVLE, so number 2 ang ginamit doon na representation. So as the conductor rotating, it cuts lines of force or lines of flux, and it produces an alternating voltage or alternating current. Number 3 is by changing the number of magnetic lines of force that link with wire or coil of wire. So in the first of this, the voltage is said to be an induced EMF, and in accordance with Faraday's law, its magnitude at any instant of time is given by the equation E is equal to N dφ dt times 10 raised to negative 8, where your N is the number of turns in the coil and dφ dt is the rate at which the flux in Maxwell's changes through the coil. By the second and third method, there is actual physical motion of coil or magnet, and in altered positions of coil or magnet, flux through the coil changes. A voltage developed in either of these ways is said to be a generated EMF and is given by the equation E is equal to BLV times 10 raised to negative 8. So B is the flux density or lines per square inch, and L is the length of wire in inch that is moved relative to the flux. V is the velocity of the wire inch per second with respect to the flux. So generation of alternating EMFs. The machines which are used to generate electrical voltages are called the generators. The generators which generate purely sinusoidal AC voltages are called the alternators. So alternators because from the word alter, alternating, and nators, generators. So alternating generators or alternators. The basic principle of an alternator is the principle of electromagnetic induction. The sine wave is generated according to Faraday's law of electromagnetic induction. So it says that whenever there is a relative motion between the conductor and the magnetic field in which it is kept, an EMF gets induced in the conductor. So this one, this is the brushes of your alternators, and magnets. These are the magnets. slip rings, and your load, external circuit. So at this position, when the conductor is perpendicular to the lines of force, so wala siyang nag-generate na current or voltage. So if we move the conductor in which manner that the lines of force is parallel with respect to the lines of force, it actually generates the maximum voltage or current. So when again, at this point, it decreasing as the conductor rotates again at 180 degrees and it reaches 180 degrees. So increasing again until the conductor will be at parallel with respect to lines of force, so it generates the negative maximum voltage or current. So the complete cycle will be at a perpendicular position again. It reaches the 360 degrees or the zero EMF. So you can generate maximum voltage or currents in the position of when the lines of force is in parallel with respect to the conductor. So working, the coil is rotated in an anti-clockwise direction. While rotating, conductors A and B and CD cut the lines of flux of the permanent magnet. Due to the Faraday's law of electromagnetic induction, an EMF gets induced in the conductors. This EMF drives a current through the lamp connected across the brushes. So, at this point, at maximum, dito, so yun yung point na pinaka-bright yung lamp, as well as in your negative half cycle. So, at this point, hindi pa masyadong bright. So it increases, also the brightness increases until it reaches here and again decreases. So magdidim na naman yung bulb nyo until it will off at this position 180 perpendicular. The conductor is perpendicular to the lines of force or lines of flux. The fact that the voltage developed in a coil of generator changes, number one, in magnitude from instant to instant as varying values of flux are cut per second. So in direction as coil sides changes position under north and south poles implies that an alternating EMF is generated. So in general cases, assuming uniform flux density distribution between north and south poles, the generated voltage in a coil will be E is equal to EM sine theta, where your small e is the instantaneous voltage and EM is the maximum voltage. Sine theta is the direction of your, so basically this EM here is the magnitude and sine theta is the direction. Okay, so we will illustrate here. So this one is a sine wave. So the equation of this sine wave, we said that E is equal to EM sine theta. This E here is the instantaneous voltage. So for example, you want to get the voltage, instantaneous voltage at this point. So what is the value of E here? What is the value of E, and so on and so forth. Kung saan mo gustong i-compute yung instantaneous voltage. So you can use this formula. EM, the value here, EM, and also the direction of your sine wave. So remember this formula, E is equal to EM sine theta. For instantaneous current, the same. ang nagiba lang ay yung I is equal to Im sine theta. Small I is the instantaneous current. Im is the maximum current. So mode of calculator should be converted to radians to calculate the sine of the angle expressed in radians before substituting in any of the above equations. So if we are using this formula, Em sine theta, be sure that your calculator is in radians. Because if we use, of course, pi over 2 pi are in radians. So be sure that your calculators are in radians. So if you are dealing with 90 degrees, 270, 180 degrees, 360, or 30 degrees, of course, your calculator must be in degrees. If you are dealing with pi's, your calculator must be in radians. Different forms of EMF and current equations. So for alternating EMFs, this is alternating voltage and alternating current. For EMF, E is equal to Em sine theta. And also our theta is in the form of omega t. This is our direction, diba? This is sine theta. And theta is omega t. So we can express this equation that is equal to Em sine omega t. And again, your omega is expressed in 2 pi f. So omega is 2 pi f. 2 pi because it represents the one cycle. And f is the frequency of the alternator. So also we can express this equation into Em sine 2 pi ft. But frequency is also equal to 1 over t. T is the period in our sine wave. So also we can express E is equal to Em sine 2 pi t over t. T here is the time. Okay? Applies only if it starts at t is equal to 0. So alternating current, same. I is equal to Im sine theta, but theta is omega t. So we can express our instantaneous current to be I is equal to Im sine omega t, and omega is 2 pi f. Other equation is the Im sine 2 pi ft. Also, frequency is expressed in 1 over t. So our last expression for instantaneous current is I is equal to Im sine 2 pi t over t. So this only applies if your time starts at 0. This one. So what if our equation or our wave did not start at 0? So here, this is our Em sine theta. But there are instances that it is not exactly at time is equal to 0. So example is this broken line. This is our reference. And the wave starts at this point. So the equation will be E is equal to Em sine omega t plus or minus phi. This phi is the phase angle. It is the angle from the start up to the time is 0 at this point. Phi. So E is the instantaneous voltage. Em is the maximum voltage, angular velocity, omega. And phi is the phase difference. So positive when it starts at the positive half cycle, and negative if it starts at the negative half cycle. So like this one. So this is a positive phi. and this is a negative V. So this is negative V. It started at the negative half cycle. So other formulas, E peak to peak or maximum to maximum is twice the maximum. So if we have a sinusoidal here, this is the EM and another EM. E maximum to maximum or E peak to peak, that is equal to twice the maximum. Of course, the magnitude here is the same as the magnitude at the negative half cycle. E maximum, this one, is equal to E RMS multiplied by square root of 2. So E RMS is the root mean squared times square root of 2. E maximum to maximum also is equal to E average times pi. So it is applicable also in maximum currents. So I maximum to maximum is equal to twice the I maximum. I maximum is equal to I RMS times square root of 2. I maximum to maximum is equal to I average times pi.